The four resistors 20 ohms, 40 ohms, 20 plus X ohms, 80 ohms respectively form a Wheatstone bridge. Find the value of X. Here, the balancing condition of Wheatstone bridge is to be understood by using the formula R1 by R2 is equal to R3 by R4. On substituting these values 20, 40, 20 plus X and 80 in the given formula, we get X is equal to 20 ohms. In a potentiometer arrangement, a cell of EMF 1.25 volts gives a balance point of 35 centimeters length of the wire. If the cell is replaced by another cell balancing point shifted to 63 centimeters, what is the EMF of the second cell? Here the problem is that we have to find out the EMF of the second cell when the balancing length is shifted to 63 centimeters. Epsilon 1 by epsilon 2 is equal to L1 by L2. On substituting these given values, 1.25 by epsilon 2 is equal to 35 by 63. On simplifying it, we will get epsilon 2 is equal to 2.25 volts. Now let's move on to the next problem. If 1 microgram of 92 uranium 235 is completely destroyed in an atom bomb, how much energy will be released? It is a problem basing on the Einstein's energy relation E is equal to mc square. 1 microgram is equal to 10 power minus 6 gram, that is equal to 10 power minus 9 kgs. Velocity of light C is equal to 3 into 10 power 8 meters per second. On substituting these values in E is equal to mc square and simplifying it, we will get 9 into 10 power 7 kgs. A transformer converts 200 volts AC into 2000 volts AC. Calculate the number of turns in the secondary coil if the primary coil has 10 turns. So according to the given problem, Ns by Np is equal to Vs by Vp, transformer rule. Ns by 10 is equal to 2000 by 200, therefore Ns is equal to 100. Number of turns in secondary coil is 100 turns. The basic formula used is ratio of number of turns in secondary coil to number of turns in primary coil is equal to ratio of voltage in secondary coil to voltage in primary coil. A small angled prism of 4 degrees deviates a ray through 2.48 degrees. Find the refractive index of the prism. For a small refractive index prism, A is equal to 4 degrees. Angle of minimum deviation dm is equal to 2.48 degrees. Refractive index N21 is equal to how much? dm is equal to N21 minus 1 into A. Once we find N21 value, we will get N21 is equal to 1.62. For refractive index of the prism is equal to 1.62. A concave mirror produces an image of long vertical pin placed 40 centimeters from the mirror at the position of the object. Find the focal length of the mirror. According to the mirror formula, 1 by f is equal to 1 by u plus 1 by v. Therefore, object distance and image distance are minus 40 centimeters respectively. On simplifying and substituting these values here, 1 by f is equal to 1 minus 1 by 40 plus minus 1 by 40. F is equal to minus 20 centimeters. Here the minus sign indicates it is a concave mirror. Focal length of concave mirror is equal to 20 centimeters. So let's move on to the next problem. Two slits are made 1 millimeter apart and the screen is placed 1 meter away. What is the fringe separation when blue-green light of wavelength 500 nanometers is used? It is given that d is equal to 1 meter. Wavelength is given to be 500 nanometers, that is equal to 500 into 10 power minus 9 meters, 5 into 10 power minus 7 meters. D is equal to 1 millimeter, so that is 1 into 10 power minus 3 meters. Fringe separation is equal to d lambda by small d. On substituting the given values in the formula, we get 5 into 10 power minus 4 meters, that is equal to 0.5 millimeters. 3 capacitors of capacitances 2 picofarads, 3 picofarads and 4 picofarads are connected in parallel. What is the total capacitance of the combination? What is the charge on each capacitor if the combination is connected to a 100 volt supply? According to the formula of capacitors connected in parallel, Cp is equal to C1 plus C2 plus C3, that is equal to 2 plus 3 plus 4, 9 picofarads. For each capacitor, V is equal to 100 volts because it is connected to 100 volt supply. Q1 is equal to C1V, 2 into 100, 200 picofarads. Q2 is equal to C2V, 3 into 100, 300 picocoulombs. Q3 is equal to C3V, 4 into 100, 400 picocoulombs. Now let's move on to the next problem. What is the de Broglie wavelength associated with an electron accelerated through a potential difference of 100 volts? It is given that V is equal to 100 volts. Now what is the wavelength lambda? Lambda is equal to 1.227 by square root of V. That is equal to 1.227 by root 100. 1.227 by 10, 0.1227 nanometers. The work function of cesium is 2.14 electron volts. Find the threshold frequency of cesium. Here it is given phi naught is equal to 2.14 electron volts. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. That is equal to 2.14 into 1.6 into 10 power minus 19 joules. If Planck's constant H is equal to 6.63 into 10 power minus 34 joule second. Frequency, threshold frequency nu naught is equal to how much? We know that phi naught is equal to H into nu naught. Nu naught is equal to phi naught by H. And substituting these values in this formula, we will get nu naught is equal to 5.16 into 10 power 14 hertz. An open pipe 85 centimeters long is sounded. If the velocity of the sound is 340 meters per second, what is the fundamental frequency of vibration of the air column? Here it is given length of open pipe L is equal to 85 centimeters, which is equal to 0.85 meters. Velocity V is equal to 340 meters per second given. Fundamental frequency N is equal to, according to open pipe, V by 2L. And substituting this V 340 and 2 into 0.185 and simplifying it, we will get 200 hertz. Therefore, fundamental frequency of the air column in open pipe is equal to 200 hertz here. A closed pipe 70 centimeters long is sounded. If the velocity of the sound is 331 meters per second given, what is the fundamental frequency of vibration of the air column? Given length of the closed pipe L is equal to 70 centimeters, that is equal to 0.7 meters. Velocity V is given to be 331 meters per second. Fundamental frequency of closed pipe M is equal to V by 4L. 331 by 4 into 0.7. On simplifying it, we will get N is equal to 118. N is equal to 118.2 hertz.